Hello, this is Mr. Huber. In this lesson, we're going to look at binomial radical expressions. Remember, binomial would mean two terms, and we're going to look at adding and subtracting when we have those multiple terms in our expression. Okay? So when we add and subtract radicals, it's like adding and subtracting other like terms. Okay, like we can't add 2x and 5y because one has an x and one has a y. Well, with radicals, like radicals, are ones that have the same index, the n, the root. These have to be the same root, and if they are, and what's inside the radicands are the same, then we can add the a and the b out in front. Okay, so you can see right here, as long as this x and x are the same, the n and the n are the same, over here that doesn't change, and we're going to add those numbers in front of the radicals. Just like if we had 5x plus 7x. We could add those together and we'd get 12x. We add the 5 and the 7 together and the x stays the same. So here we'd add the a and the b together, and this part, the radical part, stays the same in our like radicals. So let's see some examples of what this looks like. Alright. The first example, 12 and then square root of 3y minus 5 square root of 3y. Again, we've got square root and the 3y inside both of them. So all we're going to need to do here is subtract the 12 minus 5 and get 7 square root of 3y. In the next example, we have x squared square root of 7 plus 6x squared square root of 3. So they're both square roots, square root and square root, but this is square root of 7, this is square root of 3. We cannot add these together. What we see right there would be our final answer. We cannot simplify that any further. In the next example, we have the same root. Okay, they're both third roots. And then we have 5xy inside the radical sign. So we can add, in this case, we're adding the 7 and the 4 together. And we'll end up with 11 and then cube root, that 3 a little better, 5xy. So again, we add the 7 and the 4 to get the 11, and the radical part stays the same. Like radicals, we add them, we add the number in front of the radicals, and the radical itself stays the same. A little triple-double trivia. Who's the first player in NBA history to average a triple-double for an entire season? Relatively recently, Russell Westbrook was able to do this, and it had been a long time since it happened, only the second time. And so the person who did this first was Oscar Robertson. He was nicknamed the Big O. You can see a couple of shots of him here in action. And actually, in 1961-62 season, just his second in the NBA, he averaged a triple-double. You can see here 30.8 points a game, 12.5 rebounds, and a little over 11 assists per game. Pretty remarkable stat line to do that. That would be great to have for one game, let alone average that for an entire season. And you can see there his career averages. He was quite an exceptional player back in his day. The Big O. All right, let's look at a couple more examples of adding or subtracting, so combining like radicals. In this next example, we see 3 radicals. That's fine. We can add and subtract 3 terms together. What we need to have, though, is the same radical. We have square root of 12, square root of 75, and square root of 3. We can't add those as they are. But we can simplify each of these first to see if that will help us go any further. So the square root of 12 can be simplified to 2 square root of 3. Because 12 is 4 times 3, so we know the square root of 4, which is 2. And then plus, and 75 is 25 times 3. We know the square root of 25, that's 5 square root of 3. Minus, the square root of 3 can't be simplified any further. So now we've got the same radical. Square root of 3, square root of 3, square root of 3. Right, you want to make sure you know how to get from the square root of 12 to 2 square root of 3, and from square root of 75 to 5 square root of 3. That's nothing new for this particular lesson, but we need to be able to do that so now we can see that these are like radicals. We have 2 plus 5, that's 7, minus, nothing in front here means there's a 1. So again, 2 plus 5 is 7, minus 1 would be 6 square root of 3. That would be our final answer. In the next example, maybe a little trickier here because we're going to have cube roots, but they're all cube roots. So now we need to see, can we get the same number inside that radical sign? All right, so 5 cube root of 32. So let's write this out even a little further. this would be 8 times 4. Why am I making it 8 times 4? Well, I want to find a number that I know the cube root of. I have the cube root of 8 as 2. So this would become 10 cube root of 4. Add our root there. 10 cube root of 4. Our next example, or term, if you will, is going to be the cube root of 108. So we want to try and see if there's some number we might know the root of. In this case, we can try some different things. 27 is another number we know the cube root of, which is going to be 3. And 27 times 4 will give us 108. So this will be minus 3 cube root of 4. And then this next part, we're going to have plus 8 cube root of 125 times 3. 125 is 5 times itself 3 times. 5 times 5 times 5. So therefore I can know the cube root of 125 is 5. When I bring that out, it multiplies by the 8, just like here. Remember, cube root of 8 was 2 times 5. That's how we got the 10. Cube root of 125 is 5 times 8. So that's going to be 40, and then cube root of 3. So now I've got cube root of 4, cube root of 4, cube root of 3. So I want to go back and see, I can add these first two terms together. The second one I can't, but I did simplify it. It's okay. Right? And I can subtract here because I have 10 minus 3. So that's going to give me a final answer in this case of 7 cube root of 4 plus 40 cube root of 3. And that would be my final answer. I can't combine those two terms because they're not like radicals. Right? So you want to add and subtract the numbers in front of the radicals if the radical itself is like. So here, cube root of 4 and cube root of 4 can be combined. Here, cube root of 4 and cube root of 3, not like radicals. I can't combine these. But here I could add or subtract the numbers in front of the radicals as long as these parts are the same, and then keep that due to our final answer.